Hey, today we're continuing on with our topic of circles, and we're going to talk specifically about chords. Now, remember that chords go from one point on the circle to another part of the circle. Now, it does not necessarily have to pass through the center. I could draw another one, let's say here. Whoops. Like this. As long as one endpoint touches the other, it could go clear across. Go like this. So all of these lines that I've drawn now are in fact chords. So what makes chords so special? If you take a look here, it says in the same circle or congruent circles. Remember, we talked about this in our last video about chords being congruent. Okay, it has to be in the same circle, so the arcs are the same in the same circle or congruent circles. And I'm looking at chords that are congruent in the same circle or congruent circles. So the two minor arcs that they make, so for example, arc AB, let me get a pen here, the arcs will be congruent and vice versa. Remember, if and only if statements say that I can go forwards and backwards, so if I know the arcs are the same, then the chords that make them are the same. If I know the chords that make arcs are congruent, then the two arcs must be the same. Alright, so if the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord. So in the case of what we're looking for, DE and EF are going to be equal lengths because the diameter meets the chord at a right angle. And then, since those are equal, we know that the arc DG and GF are congruent as well. So, because the diameter will bisect the arc that the chord DF made. So we'll know that DG, excuse me. Oops, let's try this again. We'll know that arc DG and GF are equal length as well. Now the converse of this is true. If I know that the chord has been cut in half at a right angle, then that means that line JK must be a diameter and it must pass through the center of the circle. So I kind of missed there. There we go. So JK must be a diameter if it cuts a chord in half at a right angle. Alright, and the last theorem that we're going to talk about before we get into some practice problems is that if I have two chords, chord A, B, and C, D, they are congruent if and only if they are equidistant from the center. So when I say equidistant, remember the shortest distance from a point to a line is going to be a perpendicular line. So if these two perpendicular lines are congruent in length, then the two chords AB and CD must be congruent in length as well. Alright, so let's put this into practice. Now this says using theorem 10.5. This came from a textbook that was in chapter 10, and it was the fifth theorem they talked about. We don't actually call this theorem 10.5 in the real math world, but this is just so that you can go back and look and see. So if you recall, theorem 10.5 says that if the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So what's important here is that we know that arc KM and arc MN are equal measure. Therefore, we can set 5x equal to 7x minus 16 because the diameter LM cuts the chord at a right angle. So what we're going to do is we are going to subtract 5x from both sides. So I'm left with 0 equals 2x minus 16. Let's add 16 to both sides. I get 16 equals 2x. Whoops. And then we want to divide by 2, so I get x equals 8. Now the question was not what is x. The question was find the measure of arc KM. So it would be 5 times 8, or 40 degrees. Alright, so in this case we're going to use theorem 10.7 that says if the chords are equidistant from the center, then the chords must be of equal length. So it says if MN is 16, so I know the chord length is 16 and RT is 16, because the chords are the same length, I know that they are equidistant from the center. So the first thing I want to look at is PQ. If I were to extend PQ out, I would create a diameter that meets a chord at a right angle, which means that P P bisects MN, which means that the length of PN must be half of 16, which is 8. If you take a look here, you'll notice that we have a right triangle. So we can actually use Pythagorean's theorem to find the missing side PQ. So what actually goes here is the 1/2 of 16, or 8. So let's use Pythagorean's theorem to find the missing side. So it's 10 squared equals a squared plus 8 squared. Doing some math, I get a squared equals 64. So, because 100 squared minus, nope, not 64, excuse me, 36. Because 100 squared minus 64 is 36. Square root both sides, 6 equals a. So PN equals 6, and that PN is actually a 6, 8, 10 right triangle. This is one of our special right triangles. This is a Pythagorean triple. Oops, I meant PN equals 8, excuse me, and PQ equals 6. I'm getting my letters all confused today. So we use PQ to find QS. Since we know that the two chords are the same length, then we know that they must be equidistant from the center. If PQ is 6 in length, then doesn't that mean QS must also be 6 in length? So QS is 6. The key here is to look at this right triangle. Know that you cut it in half, 8, 10, find the missing side of 6. Here are two practice problems. Please pause and give it a shot and see if you can do it. Use example number 3 to solve number 2, and then go back and look at example number 2 to solve problem number 1. Alright, so on this one I have a diameter that meets a chord at a right angle. Therefore the chord and the arc it makes are bisected. So 7x plus 3x plus 24, or excuse me, 7x is equal to 3x plus 24. Because bisected means I cut it into 2 equal pieces. Solving for x, I get 6, plug it back in to get the measure of arc RS, 42 degrees. Over here I have a right triangle. I know that if DG and JL are the same length, then they are equidistant from the center. So then I have this right triangle. I'll make it 12 because it's cut in half. 13 is given to me in the problem, so I do Pythagorean's theorem, and I find that FH is 5, which means HK must be 5 as well. Alright, so the next theorem we're going to talk about still relates to chords. It says if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments in the other chord. What that means is that CE times ED is equal to AE times EB. Okay? All it is. So I take one chord, multiply it together, the two pieces, set it equal to these two pieces together. Basically what happens here, let's say I have a proportion and I'm missing a side. I could then cross multiply and find the missing side length because I know that these must be multiplied to be the same length. Okay? So we could say like 2 times 10 equals what times 20? Well, that would just be 1. X equals 1. Okay? So we'll have some examples of that in a minute. Now, if we have two secants, remember secants are not the same as chords. They go through the circle and continue on. If I have two secants, I know that EA times the whole length EB is going to be equal to EC times the whole length ED. So the outside piece times the whole piece equals the outside of the other secant times the whole piece. And when I say outside, I mean outside of the circle. Alright, this time we have a tangent. Notice it only touches the circle once, and a secant. Now before with the secant it was outside piece times the whole piece. That stays the same. However, the outside and the whole piece for a tangent is the same, so it's EA times EA, or EA squared. Alright, so let's go ahead and put this into practice. Alright, we're going to use the theorem that the two chords are cut, and when the product of each portion will be congruent. So I have that LJ is 10, and ln is x. So I know 10 times x will be equal to 8 times 5, or that would be KL and LM. So 8 times 5 is 40, and then I simply divide by 10 to get 4. So x equals 4. Now the problem did say find the value of x, so that would actually be it. We would be done for that problem. Alright, here we have two secants. Remember, it's the outside piece times the whole piece times the outside equals the outside times the whole. So the whole piece here is actually going to be x plus 12, and the whole piece here is going to be 9 plus 15, or 24. So if you're referring to the theorems that we're working on, this would be theorem 10.16 in your notes. So AB is 12, while AC is x plus 12. AD is 15, while AE is 9 plus 15, or 24. So 24 times 15 gave me 360. Let's use a different color. Now, to multiply this, you have to make sure you distribute to both terms. So 12 times x is 12x. 12 times 12 is 144. So by subtracting 144 from both sides, I'm going to cross this out because I would like another step. I get 12x equals 216. And what I did was I just subtracted 144 from both sides. So when I divide by 12, I get x equals 18. So it simply says find the value of x, so I don't need to plug it back in because I have found the value of x as 18. Alright, we are actually going to bypass this problem for the fact that it has the quadratic formula, and we have not discussed the quadratic formula as of yet. However, I will post the answers, and just very briefly, in case you want to give this problem a chance. So again, we have not used the quadratic formula yet. That will be discussed later. Okay? So, in case you already are familiar with the quadratic formula from your outside studies, here's the solution to the problem. Alright, so let's go ahead and do number 1. Alright, number 1 says chords MP and NQ intersect inside the circle. Find the value of x. So what we're looking at here is we're looking at one of the theorems that we discussed earlier, and that would be theorem 10.15. What that says is that x times 4 is going to be equal to 3 times 8. So x times 4 equals 3 times 8. Now x times 4 is just 4x, and 3 times 8 is 24. So divide both sides by 4 and I get x equals 6. Because I was not asked to find a certain length, my final answer is 6. What if I said to you, find the length of NQ? Here's what you would do. NQ is going to be x plus 4. If we know x is 6, then we know that it's really 6 plus 4, which is equal to 10. Alright, here we have another problem where we have a tangent and a secant, and we want to find the value of x. Remember that it would be outside times whole piece, so that's 15 squared, equals outside 9 times the whole piece, x plus 9. So 15 squared is 225. Distributive property, 9 times x is 9x, 9 times 9 is 81. So by subtracting 81 from both sides, I get 144 equals 9x. Then I would need to divide both sides by 9, and I get 144 over 9 is 16. And then if I asked you to find the length of secant AD, it would be x plus 9 or 16 plus 9, which is 25. Alright, so before we end today, what I'd like to tell you is that there might be a little something for a pop quiz tomorrow. I am actually recording this video on my wedding anniversary, November 20th. And I have been married to my husband, and his name is Jeff, and today we are celebrating. So I know that you're not watching this video on the 20th, but however, we can call this some timey-wimey things. just keep that in mind. I'll see you guys later.